In this video, we are going to see how to solve a system of equations with two variables by graphing. To solve it by graphing, what we're going to do is we're going to graph each equation in the coordinate plane to find the solution. Remember that the solution to a system of equations, it's a value of x and a value of y that is true for both equations. Now, our first equation is going to be that one that I marked with green. And when we graph it, it will make a line. We call that line 1. Now the second equation, when we graph it, it will make another line. We will call that line 2. Now from line 1, when we graph in the Cartesian plane, we are going to get this line that we have here on the screen in green. Now when we graph the second equation, we are going to get a different line that we have here on the screen now in blue. Now I can graph those both of the equations in the same Cartesian plane, and I'm going to get this graph that I have now on the screen. And we see that they are going to cross in a point. That is called the intersection point. In this problem, in this example, the coordinate where they cross is coordinate 2, 2. So this point of intersection is the solution of the system, and that is going to give us the solution. In this case, the solution of this system is x equals 2 and y equals 2. Remember that in the Cartesian plane, the horizontal axis is called the x-axis, and the vertical axis is called the y-axis. And when we represent a point, we represent it inside parentheses, and the first number corresponds to the value of x, and the second number corresponds to the value of y. Okay? In this case, both of the numbers are the same, but usually we are going to get different numbers. So in order to solve a system of equations by graphing, what we need to do is graph both of the lines in the same Cartesian plane and find the intersection point. The coordinates of the intersection point will give me the solution. So let's see how to graph. We are going to graph this one, but now in steps and by hand. We are going to solve this system. 2x minus y equals 2 and x plus y equals 4. We need to graph both lines in the same Cartesian plane. We are going to start with the first one. So to graph a line, we need at least 2 points, 2 coordinates, to join them and then find the line. But we are going to look for 3 points. That way we make sure that we are solving our problem correctly. Now to graph one line, what we need to do is clear y and then make an xy table. So in the first equation, we are going to start by clearing y. We pass the 2x to the right, and we are left with minus y equals 2 minus 2x. But then I see that my y is negative, and I need to clear my y with a positive value. So I need to change that negative sign. The way to do that is we are going to multiply the whole equation, so both sides of the equal sign, times minus 1. Doing that keeps the same values but changes all of the signs. So we multiply everything times minus 1, and we change the signs of the equation. So it's now positive y equals negative 2 plus 2x. Okay, so as you can see, I just changed the sign of everything in the equation. Okay, now my y is cleared. So now I can find the values of x and y in a xy table. Okay, so we are going to give values of x to the equation and find its corresponding value of y. I can use any value of x that I want, but I'm going to use small numbers so I get solutions that are easy to graph. If I use larger numbers, it's going to give me large answers that are difficult to graph in a Cartesian plane by hand. So I'm going to use numbers 1, 2, and 3. So those are the values of x that I'm going to substitute in the equation that I found with the y cleared to find the value of y for each value of x that I wrote. Okay, so since this is a small operation, I'm going to do it here on the table. It says, the equation says that y equals minus 2 plus 2 times the value of x. And here I'm saying that x is 1. So 2 times 1. That's minus 2 plus 2 times 1 is 2. Minus 2 plus 2 is 0. Okay, so now I found coordinate x1, y0. Now let's do it with number 2. Minus 2 plus 2 times the value of x, which is now number 2, equals minus 2 plus 2 times 2 is 4. And then minus 2 plus 4 is 2. Now I found my second coordinate, x2, y2. Now I'm going to solve it with the value of x equals 3. The equation says minus 2 plus 2 times x, which is 3, okay, that equals minus 2 plus 2 times 3 is 6, equals 4. Now I found my third coordinate, x3, y4. And I'm going to graph it here in the Cartesian plane. Okay, so now each of this line is going to be representing a unit. So 1, 2, 3, 4. 1, 2, 3, 4. And then values positive y's. So 1, 2, 3, 4 above. Now my negative numbers go below. Minus 1, minus 2, minus 3, minus 4. I'm trying to do tiny numbers. And then as well to the left, I have negative numbers. So 1, 2, 3, 4. Let me write the numbers. Minus 1, minus 2, minus 3, minus 4. Okay, so now I'm going to graph the line. I found that I have x1, y0. x1, y0 is here. x2, y2. So x2, y2 is here. And now I have x3, y4. So x3, y4 all the way here. Okay, so the 3 points are lined up. That means that I'm correct. Now we join the 3 points with a straight line. Something like that. Okay, I already graphed the first line. Now let's graph the second equation. This one. So we have to clear y. Okay, this one is y equals, okay, the x is going to pass to the right subtracting. So y equals 4 minus x. Okay. Now I do my xy table. And I'm going to use the same values of x, 1, 2, and 3. Okay, so this is even simpler. So it's 4 minus the value of x, which is 1. 4 minus 1 is 3. Now with 2. 4 minus 2. That gives us 2. And 4 minus 3. That gives us 1. Okay, I found 3 coordinates. The first coordinate is x1, y3. So x1, y3 is here. Second coordinate, x2, y2. x2, y2. Third coordinate, x3, y1. x3, y1. It's here. Okay, now I am going to join the 3 points with a straight line. The best that I can is that. Okay, now I have to look for the intersection point. And I see, let me change color, that the intersection point is here, the point where both lines are crossing. And the x coordinate of that point is 2, and the y coordinate is 2. Okay, so it's the same problem we had in our introduction. So I already know the solution. The solution is x equals 2, y 2. Now, let's see an example with different values. Now, let's solve this system of equations. So we are going to start by clearing the value of y in our first equation. I'm going to do it here. So y equals 1 plus 3x. Okay, now that we cleared y, we are going to make the xy table and give values to x. Now I'm going to use a negative number and 0 and a positive number. So minus 1, y, and 1. 0 and 1. Okay, so when x is minus 1, let's substitute in the equation that we cleared for y. So y is 1 plus 3 times x, which is minus 1. Now 1 plus 3 times minus 1 is minus 3. So it's actually 1 minus 3 that gives us negative 2. Now 1 plus 3 times 0. 3 times 0 is 0, so that's 1 plus 0, that's 1. Now 1 plus 3 times 1. That's 3 times 1 is 3, so that's 1 plus 3, that's 4. Okay, so now we have our 3 coordinates for the first line. Let's graph them. X minus 1, y minus 2. That's here. Minus 1, minus 2. Now x0, y1. That's here. Now x1, y4. 1, 2, 3, 4. That's here. We have our points lined up, so that means that it's correct. Now let's join it with a straight line. There it is. Okay. Now let's graph our second line. Number 2. We are going to start by clearing y. So in here we have minus 2y equals minus 2, and negative 6x passes adding, so plus 6x. Okay, now I want the y by itself. That minus 2 that's multiplying y has to pass to the other side, dividing everything. So y equals minus 2 plus 6x over negative 2. Now that we clear y, we are going to do our xy table. xy. I'm going to use the same values of x, minus 1, 0, and 1. So minus 2 plus 6 times x, which is minus 1, over minus 2. Okay, minus 2. 6 times minus 1 is minus 6. So minus 2 minus 6 over minus 2. Minus 2 minus 6 is minus 8 over 2. And minus 8 over 2 gives us, oh, it's minus 2. So minus 8 over minus 2 gives us 4. Okay, now let's do it with the next number, with 0. Minus 2 plus 6 times 0 over minus 2 equals. Okay, here 6 times 0 is 0. So it's minus 2 plus 0, it's minus 2. So minus 2 over minus 2 gives us 1. Now let's do it with number 1. Minus 2 plus 6 times 1 over minus 2 equals minus 2. 6 times 1, oh, let me erase that. Okay, minus 2 plus 6 times 1, that's minus 2 plus 6 over minus 2. Minus 2 plus 6 gives us 4 over minus 2. And 4 over minus 2 gives us negative 2. Okay, we have our 3 coordinates. Let's start by graphing x minus 1, y4. X minus 1, y4. 1, 2, 3, 4. It's here. x0, y1. x0, y1. x1, y minus 2. x1, y minus 1, 2. Here. Okay, we can now join them with the straight line. And we see that they are intersecting at a point here, which is coordinate x0, exactly in the middle, and y1. Okay, so this is the solution to our system. X equals 0 and y equals 1. Okay, in the other examples, we didn't check. So we should have checked. Let's check in this one. Let's check our answer to see that we are correct. So it says that minus 3 times x, which is 0, plus y, which is 1, should be equal to 1. Minus 3 times 0 is 0, plus 1 equals 1, and y is 1, so we are correct for the first equation. Now let's check with the second equation. The second equation says that minus 6 times x, which is 0, minus 2 times y, that it's 1, should be equal to minus 2. Minus 6 times 0 is 0, minus 2 times 1 is 2, equals minus 2. So minus 2 is minus 2, so we are correct for both equations. You can also use a graphing calculator to get an exact graph like the one that I have right now here on the screen. There are many graphing calculators that you can find online. One that I recommend is one called GeoGebra, and it's a free program that you can use online. So this was how to solve systems of equations with two variables by graphing. Thank you for watching this video.